So I think we are done with the how to draw various forces, and now we are going to deal with the how to solve the question of Newton's law of motion. So to solve the question of Newton's law of motion, we need to understand two things. One is called the FBD, which we call free body diagram. At the same time, we also need to understand something called FD, which is called the force diagram. So in a short while, I'll explain what the difference between the two. So when I say a free body diagram, what does it mean? It is representing all forces acting on the body when the body is free from the system or all contact. Okay, so free from the system of contact means you have to show it as an isolated body, and then every possible interaction that the body can have with its contact as well as with gravity, all forces we need to represent, and we must represent by the arrow, and we must represent where it is acting. So when you do so, we call free body diagram. So for example, we have done this at individual level, but let's repeat it for one or two questions. So for example, if we have three masses, that's called M1, M2, M3. This is the simplistic example, M1. So without default, all masses must be experiencing the gravity, and gravity will pull all of them in which direction?
Downwards.
So all will be experiencing this pull. When I say FBD, we have to replace, kind of mentally remove each other. So don't try to, show in contact. You can just simply represent each. So now call M1. So the force will have two types, contact and non-contact, and gravity will be the only non-contact force that you should know. You must understand that gravity pulls because of its own behavior. So all will experience a force in the downward direction, and the way to represent is M1G is the first force, M2G. So no matter which question you are solving, you can always represent the vertical force. And you can name it M1G, M2G, M3G depending on the mass of the body. Okay. Once you're done with the gravity, which is the non-contact force, you need to think about the contact force, and for that you need to also realize that how many surfaces are in contact with the given object or body. And once you realize, then you can assume those many variables, and every contact force is the normal contact force, either a spring force or we can say tension force. Because contact force will have two types, if you remember. It's a surface contact and point contact. Surface contact will have friction and normal, and the point contact will have tension and spring force, right? Now M1 will touch the M2. So there is only one contact. So the force it will experience is, let's call N1, and it will also experience N1 downward. Okay. Is this clear? So N1 will act on M1 also, and N1 will also act on M2 also, right? Because it's an action reaction pair. Do you realize this? Yes or no?
Yes.
Similarly, M2, I have already shown N1, but for M2, there is one more contact acting from the below, from the other surface, which is, let's call M2. And the same M2 will act on the M3 in the downward direction. And finally, the ground is touching the M3, so it will exert force. You can draw the N3. So this is called the ABD. In ABD, what we do is we represent the force where it is acting. Okay. Not exactly, but the surfaces we show the forces on its respective surface. What is force diagram? In force diagram, which is a convenient way of solving question, we always represent the object by a point. Okay. And it is only a matter of convenience. As you progress, you can just replace or either one ABD or FD. You can use interchangeably as per your convenience. So I would say this is M1, this is M2, this is M3. And generally we do in the diagram itself. Okay. So let's say this is M1, this is M2, this is M3. And what we do is we represent every force by putting their arrow, the tail of the arrow at the one point. So for M1, the MG will act like this. For M2, M2G will act like this, and for M3. So we show the arrow at the object itself. I mean, the tail of the arrow will be at the object itself. So we can say this is M1G. And N1 is acting upward, so we have to draw an arrow from that same point, but in upward direction. For M2, we have two forces, N1 below, you can see. Do you see it is M1 below? And it is N2 up. For M3, it is N2 below and N3 up. So you can clearly see that all forces we have to represent by joining tail to tail. And if there are more than one arrow in the same direction, you can represent that way as well. So it is N2 up and N1 below, and this is N2 down and N3 up. So do you all realize these forces? Hello, hello, hello.
Yes, sir.
So the way of writing is you can either write the two arrow, or you can write as this is equivalent to writing N1 plus M2G, and this is equivalent to writing N2 plus M3G. So generally, if the forces are in the same direction, we can simply add them together and we can call it one force, one value of force. Okay. So when you do this, I mean, arrow, when you put the arrow exactly, if you put every arrow at the tail, or it's like if you make them co-initial vectors, then what we call is the force diagram. And in particle dynamics, it doesn't matter where we represent the force, as long as the direction is properly intact, the answer will be same. I hope this is clear. Hello, hello, hello.
Yes.
So I'll give you one or two questions just for your practice. So let's say we have a block So this is your mass, and let's say you attach some thread, and the thread passes over some pulley. Then the same thread passes over the pulley, and it is also connecting another mass. Let's call M1, M2. Okay. So this is your diagram. Can you draw the ABD of M1, M2 separately? Tell me, guys, can you draw the ABD now? Am I audible?
Yes, sir.
Yeah, so you all draw the ABD of M1 and M2 separately and send it to me quickly. Question is clear to all of you guys?
Yes, sir.
So Siddhanta, why MG is slant? MG must be in which direction? How gravity acts?
So vertically downwards.
So you have shown like this, right?
Yes,
To rectify this, this is M1T. See, we always go by the convenience. So I'm drawing the kind of force diagram. as FBD. So I'm just joining tail to tail because that's convenient. Let's call n because we have only one variable. And of course, the tension is like this. Similarly, the M2G is like this. Gravity will pull everything downward. And as the gravity will try to pull this, the tension will develop like this. And because it's the same row passing over the pulley, so tension must be same. That's the rule. So the assumption of variable is also as per the rule. So we are not supposed to make many variables. These are the sufficient variables. If you have drawn something like this, your FBD is correct. Okay. It is clear. Now,
Yes.
when you have when you know what is FBD, then how to apply the laws of motion is very simple. To solve question of laws of motion, the step one is called draw FBD of all masses and movable pulleys. So when you start, for the first time, you can see we already have a pulley here, but is this pulley at rest or is it in motion?
Rest.
So such pulleys, unless they do not ask the question based on that pulley, we never draw the ability of the static pulleys. If it is movable, we have to draw for some purpose. So we'll come to know that what is the purpose. So draw the ability of all masses and movable pulleys. As and when you come across, you should draw that way. Now I have to put an arrow here. You can draw FD directly also in the diagram itself. The second step is very, very crucial. So as a beginner, you need to realize that what would be the possible direction in which the mass can move as per the given situation. So you need to predict through your intuition or idea or knowledge of force that what could be the possible direction of motion. So analyze probable direction of motion of bodies. So the next step is you must understand what could be the direction. So here M1 will have only two possibilities. Either it can go up the plane or down the plane, correct? And M2 can either go vertically up or vertically down, isn't it? And because both are connected, so in a way, as M2 will go down, M1 has to go up the plane. There is no way out. Is this clear? Hello, what I'm saying?
Yes, sir.
So later on, you will come to know that it's called the constraint motion. Like motion of connected object is called constraint motion, because if one will move, the other will have some constraint. It cannot move the way it wants. It has to move following the constraint. So I will introduce the constraint motion separately when we will solve question like this. But there is a step 3 which says that you must resolve the forces in the direction of motion, probable motion, and perpendicular to it, because that will make it easier for you. So the next step is resolve all forces resolve all forces in the direction of probable motion and perpendicular to it, like the two mutual perpendicular components. One is in the direction which you expect it will move, and then normal to it. So tell me what is the possible direction of motion of M2? So in what possible direction M2 can move?
Vertically upwards or vertically downwards.
Exactly. And if you look at the FBD, do you see any force in any random direction apart from that up and down? Do you see that forces are already in the direction of motion itself?
Yes.
Yes, sir.
When you come across such situation, no need to resolve anything. I mean, that is perfectly balanced there. But look at M1. How M1 can move? M1 can move either up the plane or down the plane. Yes or no?
Yes.
If M1 can either move up or down, so tell me, guys, are all forces along the plane and perpendicular to plane, or do we have some force which are neither? So tell me, what about the tension force? Is tension parallel to the plane?
Yes.
What about the normal? Is it parallel or perpendicular?
Perpendicular.
Perpendicular.
So these are perfect forces because they are either along the motion or normal to the motion. But what about the M1G? Is it either parallel or perpendicular?
No.
So whenever you come across a situation where the forces are neither parallel nor perpendicular, there we do the resolution of force, or just like a resolution of vector. So we can draw a line like this. And definitely you can see the M1G is in this quadrant. The first step is to resolve any vector. We need to know the angle first. But if you assume this as theta, this will be how much? So this will be 90 minus theta. Understood? Hello. Hello, guys. Is this clear? This is 90 minus theta. Yes or no?
Yes.
Yes, sir.
If this is 90 minus theta, so this will be.
Theta.
And if this is theta, then M1G can be resolved along the two mutually perpendicular directions. So what is this component?
M1G cos theta.
So whatever is the angle, we take the cos of that angle. So if this is M1G cos theta, this will be how much?
M1G sin theta.
Yeah, it is M1G cos 90 minus theta, which is by default sin theta. So if I know one answer, I can write the other answer. See, once you resolve the force, then this force is obsolete. It is not required for you. So either you can take these component or you take M1G as a whole. You can't take both. Is this clear? Hello. Hello, guys. Is this clear?
Yes, sir.
Yes,
Now,
sir.
do we know which one will go up, which one will go down? Do we exactly know that M2 will go up or M2 will go down? Do we exactly know? Yes or no?
No, sir.
No. So when you do not know the exact direction of motion, you know that it will go either up or down, but you don't know which of the two. So whenever you do not know the answer, the simple rule is, the thumb rule is, choose whatever you want. Choose whatever you want. So choose direction of acceleration of one of the connected object. So you can choose one of them, because see, once you choose the one, other will have dependency. So it means if you know if one of the mass is moving this way, and if other masses are connected to it, it means it can also move in certain way because of this constraint. So we'll come to that constraint later on. So choose direction of acceleration of one of the connected object. What I am written, connected mass. Okay. And accordingly determine the direction of motion of other connected mass. Okay. So up to step 4, it is clear to all of you?
Yes, sir.
Now very crucial stage again. Once you have decided, let's say if I say that okay, M2 will go down by with some an acceleration A. Now this is a simple question in which if M2 will go down, M1 has to move up with the same acceleration A, isn't it? Do you realize this why? Because the length of the string is constant, we cannot alter the length. So if you increase the length on one side, the other side must decrease. And though, I mean, therefore the value will be same. So the acceleration of M2 and M1 both will be A in value, but in opposite direction, of course, I mean, in different direction. So do you realize this part? A and A are same. Hello, hello, hello.
Yes.
So this is how you assume the acceleration. In complex situation, I will tell you how to do this. So we have to study something called constant relation. But in general, if you know that if M2 is going down, the M1 will go up the plane with the same value of acceleration. Of course, the directions are different for sure.
So
Now,
if it's connected with a string, will the acceleration still be same?
no. If it is spring, then it is not constant because spring doesn't put constraint. Constraint means you cannot change the length of string. That's called constraint. And whenever there is a constant, then only the acceleration will have a relation. If it is a spring which can elongate, so it is not putting any constraint. So two masses which are connected with the spring will not have any constraint. So we'll come to that also. So choose direction of acceleration of one of the connected mass and accordingly determine the direction of motion of other mass, other connected mass. So you can call this as constant motion case. But still, even in case of spring, at least you can decide how it will move. So that's, I mean, from situation, it is obvious. What is step 5? So step 5 is crucial. Here we talk about the constant mass. So one should know that how to use the formula net force equals to mass into acceleration. So there are two ways in which you can solve question. Okay. And the method is take all forces in the direction of acceleration as positive and take all force against the direction of acceleration as negative. Add them together and then write mass into acceleration. So as a beginner, you can always think, okay, this way. I mean, this is common sense. What is the meaning of acceleration? When something is accelerating towards the right, left, up, down, or whatever, it simply means the net force is in the direction of acceleration. So what you are supposed to remember is that the net force is always in the direction of acceleration. Acceleration always represents the direction of net force. So take force or force component. Just okay. So take force or force component along the acceleration positive and opposite negative to find the net force. Okay. Now, you have to always add two things because we are going to solve mostly two-dimensional problem. So step 6, you can add like this. Take the direction of motion as one of the axis, let's call X or Y, and the direction normal to the motion as Y-axis. So let's say if the acceleration is this way, so I will choose this as X and I'll choose something like this as Y. And the way of writing the equation is the net force towards X, we write as mass into acceleration towards X, and net force Y equals to mass into. Generally, when you will solve question, you will find that in one direction the acceleration is 0, in other direction there is acceleration. So for example, here the acceleration of M1 is in which direction? You can see it is along the plane, right? Tell me what is the acceleration in that direction perpendicular to the plane? What is the acceleration in this direction? Do we have any acceleration? Yes or no?
No.
So when you do not have acceleration, you have to put 0 answer. That's it. Understood what I'm saying? If there is an acceleration, name the acceleration A. If it is no acceleration, if there is no acceleration, if it is 0, put 0. But the way of writing is net force is equals to mass into acceleration. Many times I have seen students check mass into acceleration as force. See, net force is one thing and equals to mass into acceleration is the two equivalent you are comparing. So you know how to find the net force from the ABD, and then you have to, you should know that how to equate with M times A. M times A is not force. It is equivalent of net force. It is clear what I'm saying? Don't
Yes,
write
sir.
MA as force. MA is not force. MA is equivalent of force. So to know that how much is net force, you can either write MA or you write net force. Both both are not means equivalent of each other. So we write F net from ABD and we equate with MA. I hope this is clear. Because sometimes if we know the acceleration and we have to find the unknown force. Sometimes we know all forces, we have to find the unknown acceleration. So F net is one thing and MA is another thing. Don't think that MA is force because I have seen that many students they take MA as force. It is clear? So how to write the question? Net force equals to mass times acceleration. Understood?
Yes, sir.
Yes. Okay. So we will start with something simple problem where the constant relation is not required. It is going to be the simplest possible constraint. So the first question, this is like the hello world of computer programming. So in mechanics, this question is called hello world. So the name is very famous. This is called at wood machine. So it was actually designed in Europe 300, 400 years ago. And it was actually used for the, some sort of punishment. So we will not go into that history. So we have, let's say, two masses M1, M2, connected by a simple string, massless string passing over a smooth pulley. So here pulley is smooth, massless, and which means the tension will be same on both sides of the pulley for the given string. Consider M2 is more than M1, so that we can decide that, okay, which one will go down, which one will go up. If it is not given, you can choose whatever you want, doesn't matter. Now here, the first step is draw the ABD. And if you draw the ABD, M2 will have gravity down, M1 will have gravity down. And the tension will be up, and T is going to be same here. Now, who will go up and who will go down? Tell me, guys.
M2 will go down.
Let's call A as the acceleration. Now tell me. M2 is going down, so which force must be bigger to create that direction of acceleration?
M2G.
M2G.
M2G. Okay. So how we write the net force for M2? So you're supposed to write the ABD free body diagram for M2 and M1 respectively. So for M2, the net force is how much? Tell me, what is the net force? How to write the net force?
M2G minus
M2G
T.
minus T equals to M2A.
This is the net force. This is net force is done. And M2 into A is also net force. But these are two ways of writing. Okay, so M2G minus T is the net force. That's it. Which is equals to M2 into A. It is clear?
Yes.
And for M1, what is the answer?
T minus M1G equals to M1A.
And the way of solving is very easy. You want acceleration and you want tension. So you can call equation 1, you can call equation 2. And what you do next is you simply add these two equations. So add 1 and 2. I mean, I can add here itself. So 1 plus 2 implies, if you add these two equations, what you get? The T gets cancelled, isn't it, guys? So what you get is M2 minus M1 into G equals to M2 plus M1 into A. Correct?
Yes, sir.
And then what you were looking for is acceleration. So you can say it is M2 minus M1. M2 minus M1 into G upon M2 plus M1. Is this clear? So this is the answer actually. This is the answer. So the acceleration in this case that will be, I mean, develop is this much. But once you know the answer for acceleration, M1, M2, G, everything will be given to you. So once you know that A is the acceleration, can you find the tension? So to find tension, you can substitute the value of A in either equation 1 or 2 as you wish. And tell me what is the answer. Tell me, guys, what is the answer? Everyone, please tell me the answer.
So T is equal to 2 into M1 M2 G by M2 plus M1.
Very good. So are you guys getting the same answer?
Yes, sir.
Everyone? So this is the beginning of the Newton's laws of motion. If you can understand this question, I can bet you can understand any damn question of this chapter. But the thing is, if you really understand, if you have mugged up this way of solving, this way of writing, if you have not understood, then try to understand through other examples as well. So this T equals to product of mass upon summation of mass. You will come to know later on in physics that 1 by m1 plus 1 by m2, the sum of the inverse, we write as 1 by mu, and it is called a reduced mass. So it's a technical term, and it is called reduced because the inverse summation will give you an answer which is less than the least value, which means if you add 1 by 10 and if you add 1 by 20, what to expect? What will get the answer? So this is 20, this is 3, correct? So mu turns out to be how much? 20 by 3, which is 7 point, sorry, roughly 7, right? 6.99, okay. So what you can see that this answer is less than 10 and 20 both, right? So this is less than the least value which we started with. That's why this is called the reduced mass. Are you guys getting this word? The term reduced mass? And you can continue this for the other terms also, 1 by m3, m4, m5. Here we have only 2 mass. So the reduced mass we write as product of mass upon summation of mass. And why we write so? Because the tension here is 2 mu g, is easy to remember. It's 2 mu g. Okay. Hello guys, is this clear? Is this clear, guys? Hello, hello, hello. The tension is 2 m1 m2 g by m1 plus m2. Have you all got the same answer?
Yes.
Yes.
And
So
just
I'm getting the answer as M2G minus M2 into M2 minus M1G by M2 plus M1.
so that is wrong, no? You got the access in this much,
Yes, sir.
and you know how to substitute the answer.
Yes, sir.
How? Let's say I'm
So
using the question 2. 2 implies T equals to m1 g plus a, and g plus a is how much? You can take common, so m2 plus m1 plus m2 minus m1 is how much? 2m2. Understood?
yes, sir.
So why your answer is not matching? Tell me. So what mistake you did? Tell me.
So
So
I
got your mistake?
substituted the value of A in the first equation, but then I wasn't able to solve it.
So you're not able to solve the equation, right?
Yeah.
If you put in the first question, the T is how much? M2 G minus A. And you are saying that I cannot substitute the value and I cannot solve it, right?
Right, so I got my mistake.
It is not acceptable that at this age you're not able to solve the simultaneous equation. All right. Now tell me which mass will go down, which mass will go up. Assume all surfaces to be smooth.
Sir, M2 will go down.
But does it matter how heavy the M1 is?
No, sir.
If I make M1 as elephant size and M2 as ant size, then which one will go down?
Sir, M2.
Yeah, so no matter what, M2 has to go down because M1 can do nothing. It cannot, the gravity acting on M1 is of no use, isn't it?
Yes, sir.
If you draw the ABD, you can clearly see
The normal force cancels.
the normal and the gravity is cancelling out each other, right? In fact, this will never contribute in motion, isn't it? So M1 will go, M1 has no option but to go towards right. And M2 has no option but to go down. Okay. So write the laws of motion for M1, M2. For M1, what we should write? For M1, what is the force acting in the direction of motion? Or in the direction of probable motion?
Tension.
Okay. So for M1, what is the question? Net force is how much?
E equals to M1.
And for M2?
M2G minus T equals to M2.
Very good. So can you solve these two equations to get A? Simply add these two. And once you add, what you get? M2G equals to? I can take A common. So A is how much, guys?
M2G by M1 plus M2 into A.
So this is not difficult, right? So these are the level 0 problem. Okay, what you're solving is a level 0. And I will move slowly. We will not put the burden on you at once. Show me that you are progressing. I can start giving you more and more challenging problem. And if from laws of motion, the challenge can go to a really insane level. So this is the easiest and the toughest chapter, depending on what kind of question you are attempting. So it is about your effort, what level you want to go with. So this question I gave you a few moments back. Now again solve it. In mechanics, there is nothing like a level of problem. I mean, you can go to any extent. It can be really, I mean, scary. It can be really easy. So as you want to, go deeper and deeper, you will see more challenging problems ahead in the same chapter. So as a beginner, one should start with level 0, level 1. But as you progress, keep on solving laws of motion even after the chapter is over till you reach the level 4 or 5. Okay. And then I'll give you the assignment of level 4 or 5 as well. Okay, anyway, can you draw the ABD and write the question and tell me the accession? Let's say M2 is going down. I'm giving you the this idea that M2 is going down. Assume it and then solve it. Tell me quickly the answer. So as you progress, you'll get a variety of tricks also, but those tricks are only good if you have already mastered through the basic. Those who know how to solve through basic, they can use a trick in future. If you do not know the basic, better stick to the basic itself. So everyone, once you are done, send it to me. I would like to see the process also.
We have to find acceleration, right?
Yes, accession as well as tension, both. Okay, Prashant. So the answer is correct, but I'll tell you the way to solve is simply always try to add and eliminate T. Okay, so what you're doing is not a good practice for long term. Okay. Yeah, always like this, because this will help you in solving even more complex question. Siddhant, you got the answer?
Yes, sir.
Send it
I
to
just
me.
sent it. Yes, sir.
Rugved, what about you?
Yes, sir. Sending.
You don't send slow. I mean, see, you're still at the level 0 problem. These all are the very, 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 very basic. From here, we start the journey of loss motion. In fact, I haven't given you any question, any tricky question. Rugved, how you got a T cos theta minus a M1 G sin theta? What is this T cos theta?
I accidentally took the components in the rightward direction as well.
You're not getting it right. You're just doing some random stuff and getting the answer. Like some
Sir, it
random.
is M1G T minus M1G sin theta.
Yes, so write properly. No? I do not want this kind of haphazard way of writing. Write just two equation. Try to add and eliminate tension. You will get the accession. Once you get accession, substitute in one of the simple equation, get the tension. Are you doing that process? Yes or no?
Yes.
I don't see that. Your answer is incorrect entirely. Do it again. I mean, if you are, see, I think what I can see here, you're not able to realize what you're doing. I mean, you do not get the sense that, okay, this is not the right way, this is not the, I mean, in fact, you do not know what is, you do not know. I mean, it's a very dangerous situation. I mean, you don't know what exactly you don't know. And that's why you're not able to ask the right question. I can see that problem with you. You yourself is not sure about the doubts. That what I can ask and remove the doubt. You're doing some random stuff, what you're learning, I don't know. But this is not how it should go. Yeah, that's correct, Siddhant. So Rugved, tell me, do you realize what you are doing? And do you realize why you make mistake?
Yes, sir. I understood why I made that mistake.
That should not repeat again. Got the answer now?
Yes, G into M2 minus M1 sin theta by N plus M2.
Correct. And what is the normal value here? What is n value here? N is how much? Siddhant, tell me, what is n here?
Sir, minus M1G cos theta.
Y minus? You're writing value, na?
Sorry. Yeah.
Y minus? Tell me. I'm asking what is n?
So M1G cos theta in the upward direction.
What is n? Come on, yeah. What is n magnitude? What is n magnitude? What is the magnitude of n? Siddhant,
Sir, N no M1G cos theta.
that's it. Why you're saying n is minus of this, plus of this? What is this? See, n
No, sir, yeah, M1G cos theta.
minus m1g cos theta, or you can say m1g cos theta minus n equals to mass into acceleration, which is 0 in both cases, right? Because it is neither going up nor going down, so the acceleration is 0. Because of that, for static equilibrium, the forces are simply balanced. And this n is very crucial. The moment you enter the chapter of friction, you need to know the n first. So for that chapter, this n calculation is very important. Right now, we are not calculating because it is not desirable as of now. What is n here?
M1G.
M1G. That's it. Are you guys getting this? So the acceleration here turns out to be how much? M2 minus M1 sin theta. I hope this is what you got. Isn't it? And the tension is how much? Tension is
M1 M2G into 1 plus sin theta by M1 plus M2.
M1 M2 G by M1 plus M2 into 1 plus sin theta, right?
Yes, sir.
So how many of you got this answer?
Yes, sir.
Clear?
Yes.
So the last question from this simple level 0 problem, you can do this problem. If you have inclined plane on both sides, imagine this is a fixed object, fixed wedge. So it won't move, don't worry about it. And there's a pulley attached here. And a rope is passing over the pulley on both sides. Tell me the acceleration and tell me the tension. Tell me quickly. Very good. So acceleration is correct, person. So you can calculate the tension.
Sir, is it a right angle triangle or they haven't
No,
given?
no, no. Alpha beta is given. No?
Okay.
Yeah, that's correct. Yes, Ethan, that's correct. Rugved, where is your answer, guy? Tell me your answer, Rugved.
Yes, sir. I'm done.
See, you have to tell me what is happening with you. I mean, why you're not getting? Is it so difficult? Tell me the issue, what you're facing. What your mind is not controlling. Tell me.
Sir, I'm getting it as sine G into M2 cos sine beta minus M1 sine alpha by M1 plus M2.
What you're getting?
Acceleration.
A is how much?
G into M2 sine beta minus M1 sine alpha by M1 plus M2.
That's the right answer.
Okay.
Find the tension now. I hope this is done. Tension you got, Rugved?
Yes.
Okay. So how much you got tension? Tell me.
M1 M2 G sine beta minus sine alpha by M1 plus M2.
M1 M2 G by M1 plus M2 into
M1 M2 G sine beta minus sine alpha whole by M1 plus M2.
no, I think this is the answer. Is this the answer? Just check.
Yes, sir.
Which means you fail to substitute properly, right? Check the substitution.
Yes, sir. Got.
So how many of you like the solving simultaneous equation, the linear equation? solve this question. On a smooth horizontal surface, we have 3 blocks kept one after the other. And one of them is pushed horizontally by a force F. So first question is, all blocks will move with same acceleration or different acceleration?
Same.
Same acceleration.
Okay, so what will be the acceleration of all of three? A will be how much?
F by m1 plus m2 plus m3.
Very good. So can you draw the ABD of each block first of all, just for practice? Question is not important. What is important is how you draw the ABD. So please show me the ABD of each block and send it to me quickly. So there are two mistakes in your ABD Prashansa. The first is you have taken the same normal for block M1, M2 because they're touching a different surface and they cannot have same normal, right? And for M3, you haven't shown the normal at all. The rest are very good. That's correct.
The normal is supposed to be different but they'll get cancelled out.
No, normal in the vertical direction will be different, no?
Yeah, I was supposed to show it as different, but I just marked it as
Yeah,
normal.
yeah. So just change it. And for M3 also there is a vertical normal.
Yeah, I forgot to draw that.
Yeah.
I
So that's
corrected it
correct.
up.
Rest is correct. Siddhant and Raghuvat, show it to me quickly. I mean, see, it should not take that much time. I mean, I expect something to be solved in 1 minute. That's it. Yeah, all are correct. Now, fine. Proceed. Yeah, Siddhant, all are correct. Very good. So Rugved, you tell me on which block the force is applied.
The first one.
Hmm?
M1.
Now look at your ABD where you have shown.
It will be carried.
Who told you all these things? I mean, I haven't taught you anything like this, right? You're applying your own brain without thinking about the concept. And that's why I'm saying that in the very beginning, every student, I mean, those who do not understand anything, they do the same thing. So what you're doing is actually done by those who do not understand anything. You're not getting it. You're not trying to focus on what is being said to you. You're not trying to come to terms with the laws of motion, its definition. What you're doing is what you're feeling actually. Isn't it? And you write who writes normal, NORML? Use symbol, no? And for every pair you have to use different symbol. If let's say if I slap your left cheek, so will you draw the APD of slap on the right cheek also?
No.
The force, if it is shown to the first surface, it is acting there only. What gets transferred is not force. What is transferred is the contact force, which is due to the other surface. And you cannot create your own laws of motion in which you transfer the force everywhere because you feel so. So draw the ABD of M1, M2, M3 as per the rules, as per the laws of motion. So for M1, the force from the left is F, right? The gravity is down, correct? And you can see the force as N1. Then there is an action reaction happening between the pairs. So N2 will act like this. So N2 will act like this. Then M2G will act like this. And then let's say N3 will act like this. Then there is again action reaction pair. Let's call N4. M3G. So are you finding this really difficult to draw the ABD? You see, at least you tell me what you're not getting it, what you have not understood. Then only I can explain. I'm not getting what is happening with you. It's difficult for me to help you. Unless you are not, clear with the thought, okay, this is I'm not getting. I mean, I am confused with this concept or that concept. Then only someone can help you, isn't it? Probably I am not astrologer. Unless you're not going to tell me, I'm not going to understand you. Clear?
Yes. Sir.
So tell me, like, what is your, why you're getting everything incorrect every time? This is, beginning of laws of motion.
No, sir, I just thought that the force would get transferred.
Why you thought? Because you never heard the, okay, you are not supposed to apply your brain. Have you heard this term? You are supposed to apply the rules, the definitions, concepts as taught to you. Never ever apply what you feel. So you may ask yourself, sir, what are the rules? So the third law is there, which says for every reaction, there is equal and opposite reaction. And as many surfaces, as many normal will come into picture. For one pair of surface, we have one normal. How many pair of surface do you see? Tell me. Tell me, guys, how many pair of surface do you see? 1, 2, 3, 4, 5. We have 5 pair of surface. And therefore, how many normal should be there? 5 normal. You can see N1 to N5. Is this clear? Tell me, is this clear? Yes or no?
Yes, sir.
And now you, as per the ABD, because all will have the same acceleration. So what will be the laws of motion for each block? For the first mass, first M1, for M1, what is the laws of motion? Tell me real quick.
F minus N2 equals
N
M1.
equals. Tell me equals.
M1A.
Yeah. So F minus N2 M1A. What about the M2?
What?
For M2, what we should write?
N2 minus N4.
Equals to
M2A.
and for M3? Tell me for M3.
N4
Hmm?
is the
Pardon?
N4. N3A.
And then add all 3 equations. If you add all N will cancel out. What you get is is this clear, guys?
Yes, sir.
Also, you can think about the concept of system. You know what is concept of system? Because all 3 are moving together. So if I take all 3 as system, what is the net force on the system?
F.
Only F. Very good. Net force on a system is F. So that's why F equals to the net mass of system. So net force equals to net mass into acceleration. Let's say if you want to find the N2, so N2 is acting for which 2 system? So N2 is pushing which 2 block together?
M1 and
M1
M2.
and M2.
No, N2 is pushing which 2 block together?
M2
N2,
and M3.
M2 and M3, right? So this normal is pushing these 2 blocks together, isn't it?
Yes.
Yes, sir.
So we can write N2 directly as the net mass of system into acceleration. And N4 is only pushing M3, so it is M3 into A. So you can always solve the question like this by assuming the system because they have same acceleration. So it's good to assume instead of a small system, you can take one big system and write the answer at once. And that is why you will get the acceleration with ease from here. And once you get the acceleration, you can substitute here to get N2 and N4 again with ease. Is this clear? Hello, is this clear?
Yes.
Rugved, are you realizing this? Rugved, are you listening what I'm saying?
Yes, sir.
Have you realized this?
Yes.
Your yes is not very convincing. It seems like
Yes, sir.
you're saying with fear, apprehension, confusion, mystery. So we have two blocks. Of mass capital M and small m. Let me tell you guys, either you master laws of motion or you have to leave physics. Because without laws of motion, there is no physics. JEE never asks question from laws of motion. But there is no question which can be solved without laws of motion. Very ironical, right? Okay, tell me what will be the acceleration in each case? Value wise. Same or different?
It's the same.
Yeah, so if the surface is smooth, the acceleration is going to be same. And what will be the value of acceleration in each case?
F by m plus m.
Very good. So now the question is, there is an insect which is trapped between the blocks. It's a tiny insect. In which case the chance of survivor is more. So this is your question. An insect is trapped between the blocks, in which case the chance of survivor is more. So this is what you are supposed to answer. This is case 1. So you have to answer this mathematically, not emotionally.
Done, sir.
So what's your answer? Which case is
So case 1.
what?
Yes, sir.
So
Sure.
because the normal force
Yeah.
applied from the small m to onto m is lesser than in case 2.
Correct. So in the case one, the normal is pushing the small block itself, right? In case one, the normal developed between these two will push the M alone. So M is only pushed by the normal, right? Who is pushing this block? The normal itself, no? See, this force is applied to this block. Who is pushing this block? Tell me. The normal developed between the blocks, isn't it?
Yes, sir.
And this normal is going to push the block of mass A small m with the same acceleration as in the case 2, right? Acceleration is same in both cases, right? By the way, what is the acceleration in each case?
F by m plus 1.
So acceleration in each case is A by m plus m, but the normal developed between them, if you draw the ABD, the small m is pushed only by virtue of normal. There is no other force to be present there. And it is producing the same acceleration A. So if you write the laws of motion for small m itself, the n will be equal to how much? Isn't it? But if you draw the ABD here, the normal here is trying to push the capital M towards left, isn't it? With the same acceleration because A is same. So as per the laws of motion, the n dash equals to how much, guys? And clearly you can see that n dash is more than n. So the insect which is trapped between them will survive more in case of case 1 because of the small compressive force, right?
Yes, sir.
Isn't it? I hope this is clear to all of you. Rugved, questions. Tell me, guys. Is this clear?
Yes, sir.
Yes, sir.
Okay. Quickly do this problem. Let's say we have a smooth inclined plane and we have many blocks kept here. This balance of one tablet anyway. So now we have a smooth inclined plane. Tell me what is the normal reaction between the blocks? Find normal reaction between the blocks? Tell me.
Sir, is it, sir, can I say the answer?
Yeah.
M plus M G sin theta A.
Anybody else? Prashant, what is the answer?
Sir, I got it as m minus 1 g sin theta.
Rugved?
M into G sin theta minus A.
Minus
A.
A? What is A?
But I'm still doing so. Adjust that.
Okay, that's enough time. The answer is none of them is going to press any other. When something is on inclined plane, tell me guys, if this is the inclined plane and there's a block, and there's a block alone, I mean, there's nothing else. And if I have a block kept here, what will be its acceleration? Tell me the answer first.
mg sin theta.
Acceleration, beta, acceleration. So what is the net force? The net force acting on the block
Zero.
is how much?
0.
Net force on the block.
So M1G.
What is M1? It's a M only. Come on, what happened to you guys?
Sorry, MG.
What is the net force acting on the block in this question? Siddhant, tell me. What is the net force acting on the block? Tell me yes or no. What is the
Sir,
answer?
mg cos theta.
Is that the net force? Okay, draw the ABD first. Everyone, please draw the ABD. Nothing can happen. See, for me, this chapter
Sir,
teaching
mg sin
chapter
theta.
is the most dangerous part. MG center. Okay, very good. So, what is the accession?
G sin theta.
G center. Very good. So, you know the net force, you know the acceleration, isn't it? Hello, hello, hello. If you know
Yes,
the
sir.
net force, you can find the accession. No? What's the problem? Siddhant. So, what is the acceleration? Hello, hello, hello. So, the accession of this block is how much? Siddhant, I'm asking you.
G sin theta.
So g sin theta.
So, what's the problem? Why are you not saying this? Now, imagine this is G center. If I have a block kept behind it, with what accession that will also come down?
G
G
sin
sin theta.
theta.
So if I keep both block together, both will fall down with G sin theta, isn't it?
Yes.
And because both are falling down with the same accession, will they press each other? Will they
No,
press
sir.
each other? The pressing only happens when the the behind block is trying to move faster than the block in front of it. Then only it will come and press, right? But here both are capable of going down with the same accession, so they will never ever press each other. Understood? So because of the smooth plane, both will move with same accession. So just because it is kept side by side doesn't mean it will press. So normal is not going to develop. I hope this is clear to all of you. Hopefully, I can only hope. So this is the trick problem. Okay. So both will fall down with the same accession G. Sin theta, no matter what is their masses. So whatever be their masses, the accession is going to be G sin theta. And because they have same accession, so the force, the reaction force between the block will be. Is this clear? Tell me guys, is this
Yes, sir.
clear? Okay. So don't solve the question blindly. Okay, you have to think a lot. Uh, so on one side there is a monkey actually. Okay, let me do this. So the monkey having mass m, and the banana is also having mass m. So what happens? The monkey starts pulling the rope on the left side and try to climb up. Okay. Question to you is, if the monkey starts climbing the rope with an acceleration A, what will be the acceleration of the banana? If monkey starts climbing up with an acceleration A, then find the acceleration of banana. Question is clear? So to climb the rope, what monkey will do? Any guess? It will pull the rope or push the rope. What it will do? It will pull the rope downward, isn't it? So to climb the rope, the monkey is going to pull the rope downward. Imagine yourself trying to climb the rope. How you will do? You will try
So
to
pull downwards.
you will try to hold the one end of the one part of the rope, and you will move your hand to above and will try to pull your body weight up. See, you're not trying to pull the rope down, you're trying to pull yourself up, which in turn will pull the rope down. That's a different story altogether. So what do you do? Imagine if the rope is fixed. So you lift your body up or you pull the rope down. Have you ever done the rope climbing in your life? Anyone? Anyone who has done the rope climbing? Yes or no? Tell me.
Yes.
So what you do in the rope climbing? You try to hold the rope and try to lift your body, isn't it?
Yes.
Now, if the rope is free to move, it will move downward. That's simple. But if the rope is kind of fixed, hanging from the ceiling, let's say, so you will go up only. The rope will not go down, isn't it? So what you don't realize that you hold the rope with your hand, and it is the friction between the hand and the rope which is holding you there actually. And then you try to pull it down. Okay. So when you try to pull the rope, the tension acting on you will increase or remain same compared to when you are hanging from the rope. The tension will increase or remain same whether you are hanging or you are trying to pull. Imagine there is a rope, suspended from the ceiling. You're trying to hang from the rope, just hanging. So you will feel some tension in your hand. Yes or no?
Yes.
If you try to climb, will you feel the same tension or more tension or less tension?
Some more tension.
More tension.
And if you try to slip down, you will feel more tension or less tension?
Less.
Less. Very good. So if the monkey is trying to accelerate, then who will accelerate the monkey? The new tension value, isn't it? So if you draw the body of the monkey, you can say tension and below is mg. Now once you develop the tension, the same tension will appear here also and same mg. If the monkey will accelerate up, which means t is more than mg, yes or no? See what I'm saying that the monkey is accelerating upward. What does it mean? The tension is more than gravity, that's why monkey is going up, yes or no?
Yes.
So for monkey, can we have t minus mg equals to m into a?
Yes.
Now if you look at the banana, the net force is same, no? For banana, if see t is more than mg, so it is true for banana as well, yes or no?
Yes.
So what you will write? T minus mg equals to m into a dash. So from these two equations, can we say a dash is same as a?
Yes.
Tell me, guys. Which simply means if the monkey will climb the rope, banana will also start going up with the same acceleration. So if you take equal mass, then the monkey and the banana will be in front of each other always. Do you realize this?
Yes.
So as monkey will go up, banana will sorry, banana will also go up, right? Is this clear? Hello, hello, hello.
Yes, sir. Got it.
Yes, sir.
See, the net force is same for both, no? If net force is same, then they must have same acceleration because they have same mass. Hello, hello, guys. Tell me yes or no.
Yes, sir.
Net force and mass both are same, so the acceleration must be same. Rugved, tell me
Yes, sir.
what is sir? What you understood
Both
here?
acceleration are the same. Whenever the monkey climbs up by acceleration, the banana will always stay ahead in front of him.
So they have same acceleration because they have same mass and same net force,
Yes.
isn't it? Okay. Now again, there is a one typical, these all are trick problems. Okay, so let me show you some more trick problems. I haven't started the constant problem, which is a second variety. So for that, I need to teach you the constant relation, which is the challenging part of laws of motion. So find the acceleration of small m in each case. So in the first case, you know how to find the accession, right?
Yes.
So
Yes, sir.
in the first case, the answer is G by 3, which is correct. In the case 2, Roshan sir, you gave me answer for the case 1 only, right?
Yes.
So what about the case 2?
So I'm sorry.
Yes, Siddhant, what is your answer for the case 1?
So G by 3.
Very good. And about case 2?
Sir, I think same G by 3.
Why don't you solve? I mean, what is the problem with you guys? You think, you feel, you guess. Are we living our life on some probability? Or do we have a mechanism to solve the question? So what will happen to the future? If you keep on thinking and all. So actually, you're not supposed to think, solve it, and tell me the answer. That's it. Do it, everyone.
So same answer. G by 3.
So 1 second.
Yeah.
I think I got it.
The first case is G by 3, which is as per the ABD. If you draw the ABD of the second case, what will get the answer? When I say that you're pulling the rope with force 2 mg, what does it mean?
The mass is 2m.
No. When you pull the rope directly by holding it, it means the tension developed is 2 mg. So what what you all fail to understand that here the tension we must take as 2 mg. So that is the difference. Here the T is actually 2 mg.
Yes.
And that is why the answer will be how much? In case 2, T is upward. T is acting like this and mg is acting like this. What is the net force? Tell me, guys. So net force for case 2 is
mg.
how much?
mg.
It is mg upward, right? So what is the accession? Come on, if mg is the net
G.
force, if m is the mass, what is the accession? G upward,
G.
isn't it? And here it is G by 3 upward. Do you realize this? So accession in the first case is G by 3. But in the case 2 is how much?
G.
G. So they may ask you the question or answer that what is A2 by A1? And this will become the integer type question, NET, numerical answer type. Is this clear?
Yes, I got it.
These all are trick problems. That's why I'm saying you have to learn for every problem. You have to learn, understand. Okay, what is the way to solve, think, and understand. So when you pull a rope directly by your hand, what you are supposed to remember that the applied force and the tension force will be same. Is this clear to all of you? So
Yes,
you can make a note if you want. You can make a note. What you can write? When a string is pulled directly, then the tension will be same as the applied force. Okay. Not okay.
okay, sir.
So I hope you can recall and remember this in future. Okay. So I said that in most of the scenario, when we solve numerical, we assume string to be massless, but it is not the case. We are going to solve question in which we do have a string with mass. And these all are standard problem which you will face again and again throughout this course. So although you will see for the first time here, but it will keep on coming again and again in other chapters as well. By that time, you will be, of course, forgetting everything. So the next concept or question is called so we are not supposed to take all. We are not supposed to take all rope as massless. Sometimes it could be massive. So I hope you have seen the heavy rope. If you go to watch any cricket match, they have a rope, as a boundary. Okay, and that rope is really thick. If you have seen, the same rope they used to, kind of drain out the water during the rain in the stadium. Have you seen that? No. Or if you see any army training, you can see those heavy ropes are there. Or if you see some, artist is performing on a street, walking on a rope. So the tightrope walking, if you have seen, the rope is again thick. You can also see on trucks, if they are carrying the load, you can see the heavy rope. So I think if you have been a keen observer, you must have seen the heavy rope almost everywhere. Okay, it is everywhere, day
Yes.
in, day out, you can keep on seeing it. So heavy rope means it will have mass. So let me draw this. Let me give you the feel of a rope. Okay. Not nice. Yes, I don't have. This is better. Okay, so this is the heavy rope. And what we assume, okay, when you solve question, we have to make some assumption. Let's say the mass is m and the length is m, which means the mass m is distributed evenly up to length L. So you should know the unitary method. If the total mass is m, if I choose a particular length, then you can find the mass of that particular length, isn't it? Now, what will be given to you that this rope is getting pulled by a constant force F. So some guy is pulling it. Okay. Now, if you're pulling the rope at this end, the right end, the tension will be maximum at which end? The right or the leftmost? So where the tension will be maximum?
So on the right.
Very good. So as you go left, if I arbitrarily make a line at a distance x away from the force, question is how much tension is developed within the rope at this junction? So what I'm asking is called the internal force. What is the force developed internally at this junction? You cannot see these are 2-block or 3-block system. It is one continuous rope. So as a beginner, when you see such question for the first time, it is the internal force you need to realize. So here the tension, what I'm asking is which force, the applied force or the internally developed force? Tell me, guys.
Internally developed.
Internally.
Yeah, so it is internally developed force. Now, as a thumb rule in physics, whenever you come across internal force, the first step is cut the rope from there. You have to cut mentally and then draw the free body diagram, which means this should be cut into two pairs, I mean two parts, one of length L minus X, another of length X, because that is where we are looking for the answer, right? Now the F is applied where? On the right of the small part, this part, right? So this is F. Now whatever is the internal force that you can understand, because tension is having the nature to pull the object. So the tension developed here will try to pull the so the right mass is pulled left and the left mass is pulled right. Do you realize this? Yes or no?
Yes.
Now, because although I have shown you the tension and all, but this is a single piece of rope, what will be the accession of each piece? Same or different?
Same.
So will they move with different accession or same accession?
Same actually.
So accession is going to same. So what will be the accession, by the way, for the entire rope? For the entire rope, what is the net force? Rugved will tell. What is the net force for the entire rope, Rugved?
The force applied.
So F. So what will be the accession?
F by M.
So what will be the laws of motion for this part? Tell me, Rugved. If you're taking this much time, if you haven't understood anything, Siddhant, tell me the answer. Person, tell me the answer.
So F minus T equals to F.
F minus T.
No.
So is it Fx by M?
F minus T. Write the laws of motion. F minus T equals to.
So
Equals to
F
what?
minus T equals to M into F by M.
M into F by M. Oh, God. I don't know how I can teach this separately, guys. Okay, do you know when there was a chapter in class 6, the unitary method, right? So for uniform distribution, you can always apply the unitary method. Do you remember?
Yes, sir.
How you remember? The entire length L having mass M. So what is the mass of the length X? Can I do it by the unitary method?
Or M by X.
M by? Okay, you don't know unitary method as well. Very good. Excellent. How you pass class? I mean, pass the class 6, 7. I mean, did you cheat?
So is the answer F minus T into X by M?
F minus T.
Into X by M.
Whatever you're saying,
Acceleration.
whatever. So acceleration is F by M, now it's given to you. What is the mass of the right part, the X part? We are writing laws of motion for this, no? So what is the mass of this length? Tell me, guys.
XM by L.
XM by L. Very good. So mass into acceleration, right? And what about this part? What is the laws of motion? Tell me, Rugved, what is the answer for this part?
T equals x mx by L minus x.
MX
Sorry,
by?
L minus x into m by L into A.
And luckily we know the answer for A, so I can use this answer directly because I need T only, so I can choose either equation. So I'll choose the equation 2. So T equals to, and what is A? You can see the tension is so the internal force developed is actually F into 1 minus x by L. Is this clear? Tell me, is this clear?
Yes, sir.
Okay. So this was the massive row problem. They will ask you the tension as a function of x. They may give you x from the right hand, they may give you x from the left hand. You have to be careful when you derive. Okay. And it is pretty easy. Whenever they ask you the tension at a position x, cut it into 2 pieces, draw the ABD as if these are 2 objects, and then get the answer. And because tension is the internal force, you can get the answer. Similarly, so what we generally don't realize in our day-to-day life, that even if you are pushing a single wooden block, let's say you're trying to push this block, mass is m, length is l. So if you are pushing it, what will develop internally? Which force will develop? Tension or normal? Tell me.
So normal.
Very good. So if I ask you how much normal is developed at this location, which is x distance away from here, so what we'll do, you will cut from here, and after cutting from here, you can draw the ABD. So the normal developed here is pushing this part of the block, isn't it? Alone. So normal is of course pushing both part, but it is pushing this part alone. This is what I'm saying. So the LHS part, the F is acting this way, and the normal is acting this way. And this same normal is only force responsible for the motion of this part, isn't it? And to get the answer, you can add the ABD of this part. Let's call M dash. So you can directly add N equals to M dash into A, and again M dash is M by L into L minus X, and A is A by N. I mean, it's the same answer. So you may be asked to find the normal as a function of applied force in a plank. This is called plank. So when we have a block of longer length, we call it plank. Is this clear, guys? Yes or no?
Yes, sir.
Now comes the third, a variety problem. Like you have seen this from the heavy rope, monkey, banana, and so on. So you come across something simple problem which looks simple at first go, but it may appear sometimes difficult also. Look at this. So we term all question as elevator problem. So generally you have elevator. An elevator will have its own acceleration which you cannot ignore. So let's say this my elevator is going upward with an acceleration a naught, and why it is going, how it is going, that's not your concern. It is going, that's your concern. So by mechanism I'm doing this. And from the okay, that many variety of question I can ask. So let's say there is a heavy rope attached to the ceiling. From this rope we have a block of mass m. From here we have another heavy rope. From here we have another block of another mass. Let's say the mass of this rope is m1, mass of this is rope is m2. This mass is m3, this mass is m. Then I tell you some point A, then this point, this junction is B, this junction is C, and this is D. Your question is find tension at A, B, C, D. So question is clear? I hope the question is clear to all of you. Tell me guys, is this clear or not?
Yes, sir.
Okay, solve it. What you will realize that okay, every question we are solving so far having no constant relation or very simple concentration, that all will have same accession. So luckily here also the m1, m2, m3, m4 all are having same accession, yes or no?
Yes, sir.
Because they are a single system moving upward, right? So now if you look at the A point, at A point, whatever is the tension developed, that tension is pulling how much mass? The entire system mass, isn't it?
Yes, sir.
So for A, now this is the idea of system. When you know that everything is moving together, you can think all of the parts moving together as one system. So for at A, so for PA, I can draw the entire system as one object. And if I think as one object, then the total mass will be how much?
M1 plus M2 plus M3 plus M4.
And the tension will act upward TA, correct? But gravity is also acting downward, which you don't realize, right? Do you realize? This much G is acting downward. And because of elevator, there is no choice left. It is also moving with the same acceleration A naught, isn't it? So what is given to you? The acceleration of system is already given to you. And that is why you are supposed to find the unknown force. Again, apply the Newton's law. What you can write Newton's law? Net force equals to mass into acceleration. Let's call this as capital M because that's easy to write. So what we can write, guys? Tell me. What we can write? Laws of motion. Anyone? Anyone there? Hello.
T minus capital MG equals capital M A naught.
So tension at A is how much? M into G plus A naught. That's simple. And M, you can, if you want, you can at M1, 2, 3, 4 into G plus A naught. Is this clear? Once you realize this, you can find TV directly. What is TV? Now the tension at B is pulling how much mass alone?
M3, M2, M3, M4.
2, 3, 4, right? So 2, 3, 4 into what we can add? G plus A naught, right?
Yes.
Similarly, I'm writing similarly. And for TC, it is pulling which mass alone? Siddhant. TC is pulling how much mass? Upward. Alone. Okay, you are not there.
Your M2 plus M4.
Very good. So TC is pulling this much mass upward. And the TD?
M4.
Is this clear to all of you? How to solve?
Yes.
Very good. I think you have another class right now, Siddhant.
Yes, sir.
Okay. So, okay, I will share a PDF, assign it very soon, which you are all have to start solving now. Okay. So start the basic problem. Constant I will introduce in the next class, where things will not be simple. And I'll give you many tricks and try to solve all those questions. Okay. There is also trick for these questions which we have solved so far, but that I would like to introduce as at the end, because once I give you trick, you will not solve through the commons. I mean through the basic. So first you strengthen your basic and then go for